All right, if you're deep in ARE study mode, you know every single point is a battle. So today, we're going to tackle a topic that's pretty much guaranteed to show up, especially in programming and analysis. We're talking about radon. Let's break it down so you can walk into that exam feeling confident. So here's the game plan. We'll kick things off by seeing exactly why this matters for your exam. Then we'll get into what radon actually is, how to spot the risk on a site, and the big one, how we design to mitigate it. And stick around, because at the end, I've got a summary chart that's basically your cheat sheet. Okay, first things first. Why are we even talking about this? I mean, with everything you have to study, why focus on some invisible gas? Well, the simple answer is because NCARB says so. But it's more than that. It gets right to the core of our responsibility for health, safety, and welfare. And look, they're not subtle about it. This is pulled straight from the ARE 5.0 guidelines. It literally says you need to evaluate site constraints, including radon. This isn't a hint, it's NCRB's spelling it out for you. You can pretty much bank on seeing this on your PNA exam. And that right there is the big why. Protecting the health, safety, and welfare, HSW, is the whole point of licensure, right? Well, radon is a massive health risk. So knowing how to deal with it isn't just exam fodder. It's you doing your job. This is HSW made real. All right, so we know it's important, but what is this stuff? Let's dig into the science a bit, just what you need to know to nail those exam questions. Okay, here's the definition you need to burn into your brain. Radon is a colorless, odorless, radioactive gas. The really sneaky part? It's totally natural. It comes from the breakdown of uranium in the ground, and it can just seep right up through the soil and into a building. Once it's inside, it gets trapped, and the levels can build up without anyone having a clue. Okay, if there is one number you take away from this entire thing, it's this one, 4. 4 picocuries per liter. The EPA says that if a test comes back at 4 pCIL or higher, you have to take action. This is the trigger point. You will see this on the test, I promise. And just to be clear why that number matters so much, this stuff is no joke. We're talking about the second leading cause of lung cancer in the country. It's a huge, huge public health issue. So when you see a radon question, your brain should immediately flash major HSW risk. So let's put on our architect hats. We're in the pre-design phase, looking at a new site. How in the world do you spot an invisible threat before you've even drawn a single line? Well, this is your starting point, the EPA radon zone map. You absolutely need to know this for the programming and analysis exam. They might just give you a scenario, your project is in County X, and you'll need to know what this map implies. It basically breaks the whole country down into 3 risk zones. And this is how you read that map. Zone 1, the red zones, the potential is already over that magic number of 4. So building with radon resistance in mind, what we call RRNC, is pretty much a must. Zone 2, orange, you should seriously consider it. And Zone 3, yellow, is low potential. But, and this is a big but, you can find a high radon house anywhere. This map is a great first look, but it's not the final word. On-site testing is the only way to know for sure. Okay, now for the fun part, the stuff you'll see on PPD and PDD. We've found the risk. Now how do we, as architects, design our way out of the problem? This is a classic exam question. What's the difference between a passive and an active system? It's super simple. The only difference is a fan. That's it. A passive system is just a pipe that lets gas vent out naturally, using air pressure differences. An active system takes that same pipe and adds a fan to actively suck the gas out. Fan equals active, no fan, passive. So let's walk through how to build the most common setup, the passive subslab system. Think of it in 4 layers. First, on the bottom, we put down a 4-inch layer of gravel. This gives the gas a place to move around. Step 2, we lay a thick plastic sheet over the gravel. That's our barrier. Step 3, we stick a PVC pipe down into that gravel layer and run it all the way up through the roof. And step 4, and you can't forget this, we seal everything. Every crack, every pipe penetration in the slab has to be caulked shut. And boom, here it is in a drawing. This is what that system looks like. See that? You've got your gravel layer at the bottom, your sealed plastic membrane, and then the vent pipe coming right up from under the slab. It's basically creating a little vacuum cleaner for radon, collecting it before it ever gets into the house and shooting it out the roof, safely away from everyone. Okay, we've covered a lot, so let's pull it all together into one simple chart. Seriously, screenshot this, write it down. This is your ARE cheat sheet for radon. Look at this. It's all right here. What radon is? An HSW risk. The action level? 4 PCI/L. The assessment tool? The EPA map for your PA exam. Passive mitigation, the standard go-to. Active mitigation, what you do when passive isn't enough. If you can explain these 5 things in your own words, you are ready for whatever the exam throws at you. So at the end of the day, yeah, this is about passing the ARE, but it's so much bigger than that, isn't it? It's about our role as architects. Our job is to protect people from risks they might not even know exist. Understanding something like radon, well, that's not just about getting a license. That's about earning it.